All right, happy Tuesday, everyone. Hope everyone's doing well. Let's get started. We are going to keep working on 424 now. Okay, 424. How can I eliminate a variable? So we started with elimination yesterday. We're going to continue elimination today. It does get a little bit more complicated, but hopefully it makes sense. Okay. More elimination. In lesson 423, you learned how to use the elimination method to solve systems of equations. In this method, you combine two equations in a way that made one variable disappear. This method is particularly useful for solving systems of equations where neither equation is in y equals mx plus b form. Today, you will practice using the elimination method while learning to deal with various complications that systems of equations sometimes present. As you solve these systems, ask your teammates or ask yourself these questions. How can you create one equation with only one variable? That's always the goal. If we can get one variable, I can solve for that one variable. If I have two variables, then I always end up with, I can't quite get a numerical answer when I've got two variables. So you always want to try to get one variable only. How can you eliminate one variable? And how do you know your solution is correct? All right, those are the main things we want to focus on today. Here we go. Problem 466. Which system of equations below would be easiest to solve using the elimination method? Once you have explained your decision, use the elimination method to solve this system of equations. You do not need to solve the other system. Record your steps and check your solution. So I'd like you to pause the video in just a second here and look at both problems and try to figure out which one problem would be easiest to solve using the elimination method. When you think you've got the answer, please go ahead and unpause it and we'll check. All right, so hopefully you paused it. Hopefully you're able to analyze both of these situations, and hopefully it kind of jumped out at you that probably the easiest way to solve it, problem solve, would be A. Because, why? Well, because the y's right here are already in both 4y and negative 4y, so they're nice and easy to kind of eliminate, okay? So what I want you to do now is I want you to try solving that system. You're going to pause again. You're going to try solving that system and see if you solve the problem and see if we get the right answer. When you're done, please unpause and I will go through it. If you are confused as to how to do this, just walk along, don't pause it, just go along with me here. Got it? Go. Okay, so you paused it, you solved it, okay? Let's see if you got it right. So elimination, now the nice thing about elimination is that once I write it, I can just kind of work with it right there. So I'm just gonna add both of these equations. 5x plus negative 8x would give me negative 3x. Negative 4y and positive 4y would cancel out, equals negative 52 and 37 would be negative 15. And then divide both by negative 3. Isn't that so easy, like so nice when it comes out that easy like that, right? X would be 5. Now, again, please don't stop there. Now I've got to solve. And so I go back to one of these two equations. Which one of these two equations do you think would be easiest? Both are kind of ugly. So I'm going to go with the top one. So I think that's maybe a little easier. So 5 times x, which is 5, minus 4y equals 37. So 5 times 5 is 25 minus 4y. And then minus 25 minus 25. Negative 4y equals, that would be 12. Then divide by negative 4, divide by negative 4. Y equals negative 3. So my solution, okay, now I'm not done yet. There's a lot to go still. My solution would be 5, negative 3. That's the answer I'm looking for. And hopefully you remember to see that. Now again, I don't always require, but if it says it, you got to do it. So I'm going to plug them in. Okay, 5 times 5 minus 4 times negative 3 should equal 37. Let's see if that's right. 25 minus negative 3 would be negative 12 equals 37. Oh, and that becomes plus positive, which would give me 37 equals 37. So that one's correct. And I got to plug it into both of them. So negative 8 times 5 plus 4 times negative 3 should equal negative 52. So this would be negative 40 plus negative 12 equals negative 52. And negative 40 plus negative 12 would be negative 52 equals negative 52. Cool. That is the work I expect to see. That is what you should have on your paper. Please tell me you got all that work. If not, you gotta be careful because, oh, and do you see how I did it? Here's the first part, here's the second part, here's my solutions. Just kind of using my space all the way across. So yeah, hopefully it looks somewhat like that. All right, we got one more then here. Problem 467. Combine these equations. Let's see what happens. So let's combine them and see what happens. Write the equation. And again, please, at any point, if you're watching the video, at any point, if I'm going too fast, just pause it. That's the cool thing about videos. You can just pause it and write whatever you need to and then unpause it when you're done, okay? So write that down and let's add them up. Let's see what happens. So when I add these two up, I get 5x. Oh, positive y and negative 2y gives me minus y equals 11. What happened is I did not eliminate I didn't eliminate a variable, and that's the whole point of elimination, right? Is to eliminate a variable so I can actually solve it. I didn't do that there, so that's the problem there. So let's work through it. So here's a random problem. Is 2x plus y equals 10 the same line as 4x plus 2y equals 20? That is, do they have the same solution? Are their graphs the same? Justify your conclusion. Be ready to share your reasoning. So please pause and try to figure out, are those two lines the same? Are they the same thing? Are those two equations the same thing? Well, let's see. How on earth did I get from one equation to the next equation? How did I get from 2x plus y equals 10, okay? 2x plus y equals 10. How did I get from that to 4x plus 2y equals 20? And hopefully what you notice is that I multiplied them both by 2, or I multiplied the top one times 2. 2 times 2x would be 4x, 2 times y would be 2y, and 2 times 10 would be 20. Can I do that? Well, the rules say if I multiply both sides by something, it should maintain equality, right? Let's see if they give me the same line. How could I check to see if they give me the same line? Well, what I could do is, let's solve for y. So if I do minus 2x and minus 2x, I get y equals negative 2x plus 10. Okay, so I see my slope is negative 2, my y-intercept is 10. I come over here and I do the same thing. So minus 4x and minus 4x. I get 2y equals negative 4x plus 20, and then I divide everything by 2. Y equals negative 4x divided by 2 would be negative 2x. 20 divided by 2 would be 10. You get the same thing? Yes, they do. So they are the same thing. Awesome. They are the same thing. 2x plus y equals 10 and 4x plus 2y equals 20 are the same thing. Why does that matter? Well, here we go. Since you can rewrite 2x plus 10 equals 20 as 4x plus 2y equals 20, perhaps this equivalent form of the original equation can help you solve the system. Combine, let's combine that now. So instead of this equation right here, we're going to kind of cross that off. And actually, I'm going to go ahead and write it below here. So 4x plus 2y equals 20. So instead of writing that, so I can multiply all this by 2, and I got this equation down here. And since I'm just adding them up, I can do that. I can write one below the other like that, okay? All right, so now let's combine them and see what happens. 3x and 4x would be 7x, negative 2y and positive 2y would cancel out, and then 20 plus 1 would be 21. Awesome. That canceled out. Let's go ahead and then solve. So I divide both by 7, and x equals 3. Awesome. Then I plug this into, now here's the thing. Here's a very, very important thing. When you are checking your solution and you change the equation, do not ever plug this into the second. Why not? Because sometimes people make mistakes going from this first one to the second equation. And if you made a mistake there, then checking your answer, this here, for example, if you came up with, for some reason, you forgot to multiply that by 2, and you left this as 10, when you solve this, and yes, I know you would have gotten a different answer, but when you plug this in here, it would have given you the right answer based on this because your original work was the problem. So you always need to go back to the original equations to check your answers or to do any work from the second part. So the second part, I'm going to plug it in. Let's go with the top one. 2 times 3 plus y equals 10. That would be 6 plus y equals 10. Subtract 6 from both sides. And I was subtracting already in my head. Y equals 4. So my solution, 3, 4. And it doesn't say, oh, yes it does. You should have checked your solution. I almost messed up there. So again, I've got to go back to my original equation. So 2 times 3 plus 4 equals 10. Oh, I don't know why I did that. 6 plus 4 equals 10. Yep, 10 equals 10. Then I plug it into my second equation. 2 times 3, 3 times 3. Ooh, that's ugly. 3 times 3 minus 2 times 4 equals 1. So 3 times 3 is 9, minus 2 times 4 is 8, equals 1. Yep, 1 equals 1. There. Cool. All right, it worked. Good. Why was the top equation changed? Would the variable have been eliminated if the bottom equation were multiplied by 2 on both sides? Test this idea. So let's multiply the bottom one instead by 2. So cross that out. Multiply everything by 2. That would give me 6x. No, and see, maybe should have crossed it off after I saw what I was doing there. So minus 4y equals 2. And if I brought the other equation down, equals 10, and I add them up, and now 8x and negative 3y and 12. No, that doesn't eliminate a variable. That doesn't work. Okay, so I multiplied the top one by 2 because I was able to get opposites. Okay, so 2y and negative 2y, that was able to eliminate. Cool. All right. Well, there is our cartoon for the day, so that means we're done. So awesome. Hope that made sense. We're going to continue this lesson tomorrow. Please don't forget to do the review preview for today's lesson and upload that picture to Google Classroom. All right. Have a good day. I'll see you tomorrow.